All right, so we are going to start lesson 6.5, day one. Okay, so we're going to talk about properties of logarithms, and our goal today is to expand and compress or condense. All right, just like exponent rules, there are logarithmic rules. There's the product property, the quotient property, and the power property. Okay, so I wrote the exponent rule that you're familiar with over here. For the product property, when the bases are the same, the rule is to add the exponents. For logarithmic, if you have log base b of m plus log base b of n, so if you have the same base and you're adding, you can follow the log product power rule by multiplying what's being logged. So you can write it as log base b of m times n. All right, the quotient rule for exponents, when you have b to the m divided by b to the n. So when the bases are the same and you're dividing, we know that our rule is to subtract the exponents. The quotient property for logs, when you have log base b of m minus log base b, same base of n, the rule is to divide what is being logged. Okay, so notice addition pairs with multiplication, right? Addition pairs with multiplication. Division pairs with subtraction. Division pairs with subtraction. Okay. And then the power property for exponents, if we have b raised to the m, or excuse me, b to the m raised to the n, our rule is to multiply the exponents together. This one looks a little bit different. If you have log base b of m raised to the n, what you do is that exponent goes out in front of log base b. So it's n times log base b of m. Okay, and I'm going to show you each of these below. All right, so we use these rules to either expand or compress. So when you go to expand, you're going to go from a single log or single ln to multiple logs or multiple ln's. All right, so I'll give you some little quick notes as we go through the problems. You're going to first part, then power. Is my note for the first one. All right, so you're going to break apart the division first. Division pairs with subtraction. So you're going to have ln of 3x to the fifth minus ln of y. So the division pairs with subtraction. Then I'm going to break apart the multiplication. I know multiplication pairs with addition. So it's well, I don't know why I'm too low already. Hold on, I gotta move this up and start over. I apologize, but that's okay because I can explain it again. So division pairs with subtraction. So I'm going to write it as ln 3x to the fifth minus ln y. Then break apart the multiplication. Multiplication pairs with addition. So ln 3 plus ln x to the fifth minus ln y. And then finally, take care of the power or the exponent that gets written out front. That's the power property, the last property. So it's ln 3 plus 5 times the natural log of x minus ln y. All right, and that would be your final expansion. So notice when you expand, you go from a single ln to multiple ln's. Okay. Make sure there are no powers at the end. You should have no exponents left at the end, which I don't. So we're good. All right. The next one, we have log base 3 of the square root of 5x. I wasn't sure. I can move up. Wasn't sure if the square root was over both the 5 and the x, but it is. Okay. So it's over both of them. All right, so what you're going to do first for this is actually rewrite it with an exponent instead of a square root because we didn't look at any properties that dealt with square roots. So let's rewrite it as log base 3 of 5x raised to the 1/2. All right, so now you actually have two options. I would actually apply the 1/2 to both the 5 and the x. All right, so I would rewrite it as ln base, or sorry, not ln, log base 3 of 5 squared. and then times, oh, hold on a second. I wrote the wrong thing. Let's start that part over. So I'm distributing the 1/2. So log base 3 of 5 to the 1/2 times x to the 1/2. All right. Then what I would do is I would break apart the multiplication. I know that multiplication pairs with addition. So I'm going to have log base 3 of 5 to the 1/2 plus log base 3 of x to the 1/2. Then I would take care of the exponents, the powers. They get written out front. That is your power property. So I have 1/2 log base 3 of 5 plus 1/2 log base 3 of x. Okay, so that would be your final answer. There is one other option for this problem, so I'll run through that quickly. The other option, still start by rewriting the square root as the 1/2 power. Now, what you could do, even though so far I've always said break apart first, then take care of the power, since the power is kind of locking the 5 and the x together in the parentheses, you could write that 1/2 out in front. But notice what I'm going to do. I'm going to write 1/2, and then I'm going to have some brackets and write log base 3 of 5x. Now, inside the brackets, I'm going to break apart the multiplication with addition. So I have 1/2, and then I'm going to have log base 3 of 5 plus log base 3 of x. Now, the reason the brackets, or you could have used parentheses, are important is because that 1/2 has to be distributed to both. So it will be 1/2 log base 3 of 5 plus 1/2 log base 3 of x. So you can end up with the same answer as long as you understand when you put that 1/2 out in front and then you break up anything that's inside the parentheses, that 1/2 has to be applied. You're going to have to distribute it. Okay. And sometimes students forget to do that. All right. Okay. Number 1 in the next example, we're going to condense. So condense is going the opposite direction. Condense means we're going to go from having multiple logs or ln's to a single log or ln. All right. So to condense, you're going to actually go in the opposite direction. If there are any powers, any exponents, any numbers out in front, take care of those first, put them back up in the exponent, and then put together. So I'm going to say powers, then together. All right. So again, that means take care of your exponents first, then start from left to right, taking care of the addition and subtraction. So the 4 goes back in the exponent. So I'm going to have log of 6 plus log of 3 raised to the 4th minus log of 3. All right. Then from left to right, addition pairs with multiplication. So I'm going to have log, and this is base 10. This is all common base, but log of 6 times 3 to the 4th minus log of 3. Now, if you want, you can do 3 to the 4th, 3 times 3 times 3 times 3, that's 81. And then 81 times 6, that's log base 486 minus log of 3. And then the subtraction pairs with division. So I'm going to have log of 486 divided by 3. And then if it is divisible, go ahead and divide. So you're going to have log of, that would be 118. That's going to be 6, 2, 162. Okay. So it's either log base 10 of 162 or just log 162. Because if the base isn't written, we know it's automatically a 10. All right. Let me see what else we have for this lesson. Okay, so now it says use log base 3 is approximately 1.262 and log base 3 of 5 is approximately 1.465 to evaluate each logarithm. All right, so for these, you're going to expand and then substitute. So what I mean by that is since I know division pairs with subtraction, I can rewrite this as log base 3 of 4 minus log base 3 of 5. And now since I know log base 3 of 4 is approximately 1.262, and since I was told that log base 3 of 5 is approximately 1.465, I can substitute those in, subtract, and when I subtract, I get that the evaluation is negative 0.203. Okay, so you're trying to rewrite all these problems in terms of log base 3 of 4 or log base 3 of 5. So log base 3 of 20. Well, 20 is the same thing as 4 times 5. So I could rewrite this as log base 3 of 4 times 5. Okay. And since multiplication pairs with addition, when I'm talking about my rules, my properties, I can write this as log base 3 of 4 plus log base 3 of 5. And now I can substitute in log base 3 of 4 is 1.262 and log base 3 of 5 is 1.465. And when I add, I get 2.727 for the evaluation. Log base 3 of 25. Well, you have two options here. You could write this. Let me erase what I have so far so I have more room. So I'm going to do this two different ways. Okay, I could write it as log base 3 of 5 times 5. Or I could write this as log base 3 of 5 squared. Okay, multiplication pairs with addition. So I'm going to write it as log base 3 of 5 plus log base 3 of 5. Over here, my exponent goes out front and I have 2 times log base 3 of 5. So if I use this method, I'm now going to substitute in 1.465 plus 1.465. Over here, I'm just going to have 2 times 1.465, which I'm hoping you guys realize you're going to get the same answer either way. You're going to get 2.93, excuse me, 2.93. Okay, so you have two different options on how to go through number 3. So again, the goal here is when you're given two different approximations, try to expand the problems in terms of log base 3 of 4 and log base 3 of 5, and then substitute. Okay. All right, so we have some more practice problems below. At this point, if you want to pause the video and try the problems on your own first, you have 2 expanding, 2 compressing, and then 4 evaluating. It might be a good idea to just pause the video, take a minute and try the problems on your own, and then come back to see how you did. Okay, so go ahead and pause and try, and then come back and I'll walk you through them. All right. So for the expanding, I'm going to first break apart and then take care of the power. So multiplication deals pairs with addition. So I'm going to have log base 6 of 3 plus log base 6 of x to the 4th. Then I take care of the power. So log base 6 of 3 plus 4 times log base 6 of x. Okay. For the next one, I'm first going to take care of the division. So I'm going to have ln 5 minus ln 12x. All right. Then take care of the multiplication. Now, because I'm going to break this apart and there's a subtraction sign here, put parentheses. All right, because that does affect your answer. You will have to distribute that negative in. If this was an addition sign, I wouldn't worry. Or if there was nothing else to break apart, I wouldn't worry either about parentheses. All right, so I have ln 5 minus ln 12 plus ln x because multiplication pairs with addition. Now distribute that negative. So ln 5 minus ln 12 minus ln x. All right, you may have missed that part if you did this on your own first with the parentheses, and if you did, you would just have one sign that was different, okay? Compressing, so going the opposite direction. Multiplication pairs with division, so I have log, and it's base 10, of x divided by 9. Next, take care of exponents first, so I have ln 4 plus ln 3 to the 3rd minus ln 12. Then take care of the multiplication, addition, pair together. So ln 4 times 3 to the third minus ln 12. All right. Now, if you want to do 3 to the third and then times 4, you could do that, or you could leave it like this and simplify later. It doesn't really make a difference. I ran out of room. I can't write any further down. So hold on one second. I'm going to have to do the work over here. And I don't like doing that, but all right. So now subtraction pairs with division. So I have ln of 4 times 3 to the third over 12. All right. You can do the multiplication and division. And when you simplify, you're going to have ln of 9. Okay. All right. And then the evaluation problems below. Okay. So I'm going to expand and make this ln base 6 of 5 minus ln base 6 of 8, and then substitute. So I have 0.898 minus 1.161, and when I subtract, I get negative 0.263. The next one, I'm going to rewrite it as 5 times 8. 5 times 8 is 40, and then break apart the multiplication. It pairs with addition. So I have log base 6 of 5 plus log base 6 of 8. Substitute. So 0.898 plus 1.16161. And when I add, I get 2.059. All right, how do I write 64 in terms of 8s and 5s? Well, I can write it as log base 6 of 8 squared, or 8 times 8. You'll still get the same answer. Put that exponent out front, so 2 times log base 6 of 8. Now I substitute 2 times 1.161, which will give you 2.322. And the last one, how do you write 125 in terms of 5s or 8s? Well, you can write it as log base 6, and you could write 5 times 5 times 5, or just 5 to the third. I put that 3 out front, so 3 times log base 6 of 5. So I have 3 times 0.898. And when I multiply, I get 2.694. All right. Clear that. All right, guys. So that is the end of day 1, lesson 6.5. I'll see you back here for day 2. Bye.